So far we have talked about where does the concept of normal distribution come from. We have talked about what are the different types of probability distributions and where does normal distribution lie in that category. So normal distribution is a type of continuous probability distribution, and since the random variable is continuous, that means we will not be able to draw a table ourselves. We will not be able to look what the entire normal distribution looks like, because continuous means there are going to be many values. It can have any value. If it was discrete can have separate values and it is very easy to see, but continuous can have so many values that a table will be provided. We will not be asked to draw a table. Neither will be given the PDF of the normal distribution. So let me write down the definition of a normal distribution. First of all, the definition is like this. How is normal distribution expressed? The continuous random variable x is distributed normally, that means the normal distribution, where the mean and the variance are parameters. Parameter means external value that you need to do a particular sum. So they are the parameters. So this is how we define, this is the definition mathematically how we define it. So for this particular thing, the continuous random variable x, this thing is written as x is distributed, is given by this symbol. So this means this wavy symbol is distributed by the distributed normally. The symbol for the normal distribution is capital letter N. So this is the symbol for the normal distribution, and the parameters are given with a bracket. For mean we write mu, and for variance we write sigma squared. Now you need to remember that when we do statistics, when we do the steps of statistics where we have the central tendencies, this data summary, and the dispersion, we always want to know the standard deviation. The standard deviation shows us the gap from one data to another data. But this sigma squared, sigma is standard deviation, but this sigma squared represents the variance. Variance is the step that you do before finding the standard deviation. Then you find the standard deviation. So variance is sigma squared and standard deviation is sigma. Remember that. It's the step that you do before finding the standard deviation. And mean is the center of the data. So when we are talking about mean, we are actually talking about it is the center of the data. So for finding the normal distribution, we need to know what is the center of the data, and we need to know the gap between data. So for example, if you have a normal distribution like this, where suppose the mean is 5 and the standard deviation is 2, so the variance would be 2 square. We can also write 4 here, no problem, but 2 square, you will understand that sigma is 2, the standard deviation is 2. Now one thing is important to understand, that the random variable will be defined. Suppose the random variable is time taken to see the doctor. So meaning time taken may be in you're in the waiting room and you need some time before you see the doctor, and suppose it can be different time. Someone can take 7 minutes, 8 minutes, 10 minutes, 15 minutes, or 1 minute, 2 minutes, but the mean, the center of the data, the mean is 5 minutes, and the gap from one data to another data, suppose for one person is waiting for 7 minutes, another person waiting for 3 minutes. The mean is the center of the data. But if you want to know what the standard deviation is, the standard deviation is the gap between one data to another data. So the more the standard deviation, the higher the gap, and the less the standard deviation, the less the gap from one data to another data. For this is the data summary part of statistics. So if you want to take a picture of here, let me draw a horizontal number line So this number line is x. X is in minutes, so time taken waiting for the doctors in minutes. It has to be a unit. So if this starts from 0, 1 2 3 4, so this will be 5, so it will be something like this. So this will be the mean, and if the standard deviation was more, then the gap would be more from one data to another data, and it would be wider. So this is how this works. You have to understand some common examples of continuous random variables, some common examples. So some common examples would be age of a person measured in years. This is the unit, so let me write out the unit here. This is the unit of the random variable, and this is the random variable itself. So we have age and the unit is years. Then we have the height. The height can be in feet, it can be in inches, it can be in centimeter. Then we have the weight of the person. The weight of the person can be in kg, it can be in pounds. Then we can have the volume of a certain object. The volume is measured in cm cube or meter cubed. Then we can have area. Area is measured in meter squared. Then we have time. Time can be measured in hour or second or minute. Then money. Money is actually a continuous random variable, because money, the definition of money is not paper money. Paper money is called currency. It's a way of receipt for money. Money is actually the weight in gold. That was the original definition in economics. That's what money is for. So if you're thinking about the weight in gold, so money is actually a continuous data, because weight cannot be counted, needs to be measured. So money could be like that. It's a continuous distribution, continuous random variable. So these are some of the common continuous random variables, and all of these would be used for normal distribution. So you can see each of these random variables will have time. That means if you, another one is distance, so this can be in meter, this is meter cubed. So you see all these things, they have a unit, and for every unit we need different table. That is a problem. So anyway, let's talk about this later, but let me show you what an actual normal distribution look like in spreadsheet. So this is what it looks graphically. This can be found from khanacademy.org. It's a wonderful website where you get many lectures and videos, and you can also get spreadsheet here. So here, if I put the mean as 5 and if I put the standard deviation is 2, remember for normal distribution we don't input the standard deviation, we input the variance. So the variance is 4. So anyway, if you put the mean as 5 and the variance is 4, so what we get here is this normal distribution. This is the normal distribution that we get, and this is the mean. The mean is 5, and these two bar here, I'll talk about that later on. So this is what the normal distribution is. Now if you change the mean, and let me change it to 7, you will see it is moving forward, because the mean has just been more. And if I change the mean to 3, you will see that it is moving backwards. So this is how the normal distribution is moving with the random variable x. It is going from one place to another, and if I make the mean 12, you will see that it is moving furthermore. So by changing the mean, you're actually changing the position of the normal distribution, and it is moving towards the right as you increase the mean. The mean is the center of the data, so if the center of the data is increasing, it is moving towards the right, and the horizontal number line or the x-axis is the random variable that we have. So this is what it is. Let me bring it back to 5. So this is what the normal distribution looks like. So if you want to know what is really going on here, so this is the mean. This is the mean, that is the center of the data. This is the variance. So when we talk about the normal distribution is referred to as the mean comma the variance. But since we always work with standard deviation is something that we will be defining, because the standard deviation is the gap between one data to another data, the measure of dispersion. So for this particular example, when you have mean as 5 and variance is 4, meaning 2 square, so this is what the picture looks like. So this is the mean, the middle, and these two bar here is actually one standard deviation. So think about it. One standard deviation means if the standard deviation is 2 and the mean is 5, one standard deviation means, so from 5 if you go 2 step backwards, that means 5 minus 2, 5 minus 2 is 3. If you go one standard deviation forward, it would be 5 plus 2, because the standard deviation is 2, that would be 7. So this particular value here is 7, and this particular value here is actually 3, and this particular value here is 7. So this is the idea. It's a very important concept. So if you want to know the probability from here to here, there's a special rule. If you go from one standard deviation backwards and one standard deviation forward, it's usually written as mu plus minus sigma, and if you want to find the probability, that probability will be something around 68%. So let's calculate that. So let's put the value here, let's put 3 here, and let's put 7 here. So you see this value is 68.3%. This is a very important rule to remember. This is part of the property of normal distributions. If you want to find the what is the probability from the center, from the mean, and the standard deviation one step backward, another step forward, then the probability is going to be 68.3%. This is an essential part of the definition of standard deviation. Then if we talk about 2 steps, then it will be mu plus minus 2 sigma. So if mu is 5, so minus 2 sigma is going to be minus 4. 5 minus 4 is 1, and mu plus 2 sigma is mu plus 2 into 2 is 4, that is going to be 9. So that means 1 is going to be somewhere around here. This is 1, and 9 is going to be somewhere around here. This is 9. So now if you want to find the area from here to here, from 1 to 9, so it is going to be like this. This is a bigger area, and this is actually more than 90%. This is another important rule. If you want to find the area, which is probability, if you want to find the area which is 2 step standard deviation from the mean, that is going to be around perhaps 96%. Let me check. So let's put here 1, and let's put here 9. So it is 95.4%. So if you want to find the area under the curve, that is the probability. 95.5% is the area, that means it's the probability. So the probability for 2 step from the mean, so mu plus minus 2 sigma, that probability is 95.4%. and this is another essential property of the normal distribution. And for 3 steps, if you want to go mu plus minus 3 sigma, if you want to go 3 steps, then what we can do here is, so this is 5, so mu minus 3 sigma is 5 minus 3 to the 6, this is minus 1. 5 plus 3 to the 6, this is 11. So here from minus 1 is somewhere around here. You can see it's really covering almost everything, and this is 11. It's actually more or less the same. This is more or less the same. If you, let's check. So let's put -1 and let's put 11. So this is 99.7%. So actually it's covering almost the entire area. So the step-by-step probability is very important. So the 3-step is 99.7%. Then the 2-step is 95.4%, and the 1-step 68.3%. So this is how the area is represented in terms of the from the mean and how far it is step by step as in the standard deviation. Now you have seen that how the mean, if the mean changes, how it goes forward and how it moves backward as the mean changes. Now let's keep the mean the same and change the standard deviation, and let's see what happens. You can guess that the standard deviation is going to if you increase the standard deviation, the gaps are going to increase. Standard deviation represents the gap from one data to another data, and it's going to get wider and wider. The lesser the standard deviation is going to be slimmer and slimmer. The more the standard deviation is going to get wider and wider. So this is the one where we have the standard deviation is 2. So this is what it looks like. If we increase the standard deviation to 3, so immediately it goes wider. If you make it to 4, it goes even more wide. If you make it 5, remember, every time you're making the standard deviation, the variance, which is actually the parameter of the normal distribution, is getting squared. It gets even more wider. If you make it 6, even wider. If you make it 7, so you can see the effect it is happening. Then 8, 9, and it is becoming wider and flatter. 10, let me write 15. It is almost straight, becoming straighter and straighter. So let's get back to 2. So the normal distribution, you can see it becomes flatter and flatter as the standard deviation increases. Now you have to understand this is done with a software, and in the exam you will not be able to directly calculate the normal distribution by looking at the random variable, because that random variable is going to have a unit and different sums are going to have different units. But you have to do the sum in the old-fashioned way using a table, a normal distribution table. Now since the table has to be one table, it has to be unit free. Now in order to make the distribution unit free, you need to standardize it, and you have to make the mean 0. Remember, 0 has no unit. If it is mean is 5, if it represents 5 minute, then 0 means 0 minute, and 0 has no unit, so it has to be, the mean has to be 0. So we have to shift the normal distribution to the 0 position, and that's the standardized normal distribution, and that is the table that we have at the back of the book to make it unit free. So let me put here 0, and let me put here 1. Now this is what the standard normal distribution look like. The standard normal distribution has mean 0. Look here, the mean is 0 here, so it becomes unit free. These are the units, but this is unit free, and you have the standard deviation is 1, so 1 step. So this is the standard normal distribution. Without converting the sum into the standard normal distribution, we will not be able to do in our exam, because we will have no software. So this is how we convert the regular standard deviation, where we have regular normal distribution, where we have units, into unit free distribution. So we have a normal distribution like this. So x is normally distributed, and we have the mean as mu and sigma squared. Now this thing has a unit, so we need to convert this, we need to standardize it, so we need to make it unit free. So what do? We convert this to this, where the mean is 0 and the standard deviation is 1, so variance is 1 squared. So this this is very important thing. The standard random variable is z. The standard normal distribution is Z is normally distributed with mean 0 and variance 1 squared, meaning 1. So this is extremely important. So this thing has no unit, so we need to convert any question that is given in the regular normal distribution with units. We need to convert it into something that has no unit at all, and this is done by a formula called z-score formula. Very important formula. So z-score formula is z equals to the random variable which has unit minus mean divided by standard deviation. Now you might get this intuitively why this is done, because this is something like the transformations, because in transformations, you know, one of the transformation is translation, where you have fx. If fx is a picture like this, and if you want to move this picture backwards, so what you do a transformation like fx plus a, and the picture moves a unit, it becomes x minus a, it moves backwards. Then you have another transformation where you have fx minus a, when you have the picture that moves forward, because it becomes x plus a. So it is something like that. It is some sort of a transformation that needs to be done. For that transformation, look here, we are just subtracting. It's like fx minus a mu. This is how it is moving about. So if you take a look, so here, suppose it was here at 5. So it was here at 5. Now if you want to make it backwards, if you write 0 here, it is actually moving backwards. You can just see the shift. You can see the shift. It is actually moving backwards. On the other hand, suppose it was minus 5, then it would be here, and if you want to make it 0 into the standard normal distribution, it is actually moving forward. So a transformation, a translation is happening from left to right or right to left to the position where we have the normal standard normal distribution. So in the exam, a booklet will be given called Mathematical Formula and Statistical Tables. It will have some formula and it will have the normal distribution table. If you go through the pages, so you will see that it has here in S1 the normal distribution function. So this is page 20. So let's go to page. Okay, so this is the normal distribution table. So here you can see that we have values of z, and we have the probability. This psi z, this is the probability, and you can see that we have the z values here, and we have the probability for every z value here. So let me enlarge this. So when you see this, you have to understand that this is the normal distribution where we have standard normal distribution, because it is unit free. Because if different questions have different units, you cannot use different tables for this. You will be given only one table, and for this you have to convert the normal distribution into the standard normal distribution. Another thing you have to understand, this is the cumulative table. Cumulative table means everything added together. For example, the word cumulative means total. So cumulative, the word cumulative means you just add it up from the beginning. So if I say probability of x is less than or equal to 3, it means from the beginning add everything up to 3. So when you add something from the beginning, this is called cumulative. So in the normal distribution is a cumulative table. So the exam table that will be given, it is normal distribution cumulative table. It will be z is, of course, it is a standard table. So cumulative table for standard normal distribution. So z is less than a, suppose. So this will be the format that will be in the table. That means from the beginning. So this means this is z, and this is going to be 0. So if z is less than a, so if this is less than a, the table will always give you the area that is less than. That is, the probability will be cumulative. So this is what it means by cumulative table. So cumulative means you're actually finding the area from that point from the beginning till that point. Of course, since it is continuous, this and this means the same thing, makes no difference at all. So whenever you look for the table, you have to make sure that the normal distribution is in the cumulative format, meaning it is less than and this value is positive. If you take a look at the table, so when I say Z is 0.01, it means probability of Z is less than 0.01 and the area is 0.5040, meaning the probability is 0.5040. If you want to find the probability of Z is less than 1.21, so if you go through this, so we found this Z is less than 1.21. so if you find the value of Z here 1.21, that means for 1.21 Z is less than 1.21, the probability would be 0.8869. so this is what it means. So from the probability of 1.21 is Z is 0.8869, this is the probability. If I want to find the probability of Z is less than 1.19, so the probability of Z is less than 1.19, the probability is going to be 0.8830. so you get the idea. We cannot get the probability of greater than from this table, we cannot get the probability if Z is negative from this table. So you have to understand, it has to be all the time Z is less than something and it has to be a positive value. And one more thing, you will notice that they're finding the area using integration. This is the PDF that we have found. Of course they have changed it a little bit using algebra, but this is exactly as we have talked about, where we have the probability density function, and for finding the area they have to do the integration. Well, the next lecture will be doing some examples for normal distribution to see how the sum works.